Now that we know what molecules are, so which are atoms in specific ratio, and they combine by forming chemical bonds, let's go into what are organic and inorganic molecules. Any molecule which contains carbon is called as organic molecule. Anything which does not contain carbon is called as inorganic molecule. Carbon dioxide sometimes is considered as organic because it is the precursor or it is the molecule which is used by the plants to convert to glucose, um, which is a which is an organic molecule. So carbon dioxide, which is made up of carbon and oxygen, is considered as an inorganic uh, compound or a molecule. Most of the organic molecules are huge molecules. These are long chained, contains many number of carbon with different kinds of bonds and mostly covalent bond, whereas inorganic molecules are small, like carbon dioxide or oxygen, right? So hydrogen, these are like really tiny molecules, or sodium chloride. So that is another difference between the two. So when we look at the inorganic compounds, the most important inorganic compound in our body is water, right? So water has many different properties which sustains life on Earth. It can absorb and release energy slowly because of its hydrogen bonds. Okay, so that helps us to maintain a stable body temperature. It doesn't vaporize easily. And so to convert water into water vapor or to ice and vice versa requires a lot of energy. Okay, so that helps maintain a stable temperature despite fluctuations in the surrounding areas. It is an excellent solvent. It is not a universal solvent. It does not dissolve fats and lipids. So we cannot call it a universal solvent, but it's an excellent solvent. And almost all the chemical reactions taking place in the body are taking place in this medium. So it serves as an excellent medium, as an excellent solvent. It can dissolve oxygen, carbon dioxide, different nutrients, electrolytes, right, acids, bases, etc. The only thing it doesn't dissolve is lipid or fats. It does participate in chemical reactions called as hydrolysis reactions. So whenever you have any molecules or atoms combining, they require a water molecule. I'm sorry, they release a water molecule. Whenever there is a splitting um, of of a compound, right? When bigger molecules break down into smaller molecules, um, um, they require a water molecule. So that is called as hydrolysis reaction. They help in cushioning, right? So, for example, our joints are made up of, we have a special liquid in them which cushions it, right? Which cushions the joint. And the eye socket, right? The eye has fluid inside in the inner chamber and the outer chamber. That also kind of cushions. So it provides good cushion to different parts of the body. It serves as a lubricant, right? So between the bones, the joints, they contain the liquid which helps the bones not rubbing against each other. In arthritis, this liquid is gone, right? So it doesn't lubricate as well, and that causes the pain, right, between the joints, between the bones. So those are some of the properties of water. And another compound that we are going to talk about are salts, electrolytes. So salts like sodium chloride is very, very important for important component of the body, of the liquids in the body like blood. Sodium chloride, when it dissociates, it completely dissolves in water. When it dissolves, it forms sodium and chloride, sodium plus and chloride minus. These are called as ions. These are charged particles. Okay, so these are called as ions. Okay, and then we also have other things like acids and bases. Acid releases hydrogen ion, and the concentration of the hydrogen ions is going to specify whether the acid is strong acid or a weak acid. For example, hydrochloric acid is a very strong acid because it releases more hydrogen ions. In comparison, vinegar or acetic acid is a weak acid because it releases less hydrogen ions. So can we touch, if by accident we spill acetic acid or vinegar on our hands, is that okay? Yes. But by accident, if we spill hydrochloric acid on our skin, would that be okay? No, because hydrogen ions are extremely caustic. Okay, so they can dissolve everything inside. And so hydrogen ions are very, very acidic, right? So the more acidic it is, the more caustic it gets. Bases, on the other hand, they release hydroxyl ion, that is OH minus, and sodium hydroxide, which releases more hydroxyl ions, is a strong base as compared to sodium bicarbonate, which can release less amount of OH. Okay, so soaps like our detergents, okay, cleaners, they are all bases. Okay, something that we use around in the house. Those are all weak bases. When acids and bases combine, okay, like hydrochloric acid and sodium hydroxide combine, they form H2O and NaCl. So they form water and salt. Okay, so this is what pattern of chemical reaction do we see here? We see exchange reaction. So we took the hydrogen from here, combines with OH, forms H2O, Na combines with chloride and forms NaCl. So when acid and base combine, they form water and salt. So this is, so let's talk a little bit about pH, and then I'll talk a little bit about buffer system here. So the scale of measuring acid or base is called as pH scale, and it starts actually from 1 to 14, not 0. And this indicates hydrogen ion concentration in moles per liter. So pH units, okay, it is a log value, meaning that it is an exponential unit. What does that mean? So we have like pH 1 to 14. So this is 10 times more than this, the next number. Meaning, suppose we have 1 and we have 2, pH 1, pH 2. pH 1 is 10 times stronger acid than pH 2. pH 2 is 10 times stronger than pH 3, and so on and so forth, till we come to 7, which is neutral. And as we go here, from 7 to 14, this is increasing levels of alkaline or basic. So suppose I say that there is an acid which is at 2, compare that with an acid which is at 5, which is a stronger acid, and how much stronger is it? So of course you're going to say pH 2 is stronger than pH 5. And how much stronger is it? 4 times? 3 times? No. It is 10 times 10 times 10. So it is 10 to the power 3 or 1,000 times stronger than pH 5. And I'm going to ask questions like that. So a weak base, strong acid, okay, pure water, which is at pH 7. So these are all, if we want to estimate the pH, strong acid is about 2, weak base is about 7.5, right? Pure water is 7. And when we talk about physiological fluid, we're talking about blood. The blood has to be between 7.35 and 7.45. Okay, so this is called a physiological neutral. Okay, so this is a chemical neutral, right? The pure water. Whereas for physiological balance, blood always has to be maintained. pH of blood has to be maintained between 7.35 and 7.45. We'll talk about that. A small change in pH is due to a large change in hydrogen ion concentration. So as I said, pH 2 to pH 3, it is 10 times. It's a log scale. It's a logarithmic value. It is not a linear value. It's an exponential value. All right, so now we are coming to organic compounds, and we're going to break them down into carbohydrates, fats, proteins, and nucleic acids. They all have something in common, which is carbon, hydrogen, oxygen. So the simplest of them is carbohydrates, which is made up of carbon, hydrogen, oxygen. Okay, so carbon, hydrate, right? So carbon plus hydrate means carbon and one water molecule. So it is in that ratio, CH2O. So the monosaccharides, so carbohydrates are sugars, and sugars are called as saccharides. Monosaccharide means one unit of sugar. So we have glucose, fructose, galactose, ribose, deoxyribose. Glucose, fructose, galactose have the same chemical formula, which is C6H12O6. So the first one is C6H12O6, and these two, ribose and deoxyribose, is C5H10O5. So here if you see, you can see that C6, right? I cannot, okay, C6, CH2O, right? So 6 times 2 is 12 and O6. C5H10O5. Okay, so that is ribose and deoxyribose. Okay, put it here. Okay. Disaccharides, when these combine, right, when two of these monosaccharides combine, they form disaccharides. Sucrose, lactose, maltose are made up of glucose, fructose, and galactose. So these are disaccharides. Polysaccharides, glycogen in our cells are composed of glucose, many parts of glucose, and then we have starch, which is also made up of glucose. These are some of the molecules. I don't want to go through that because you really don't need that at this time. Why are carbohydrates important? Because they provide ATP. Glucose also provides sweet taste. So why use artificial sweetness, right? Okay. Place these in terms of complexity. So monosaccharides are the simplest, then disaccharides and polysaccharides. List 5 monosaccharides, list 3 disaccharides, list 2 polysaccharides. Okay. Lipids or fats are also composed of carbon, hydrogen, oxygen. There are 3 different kinds of lipids. Triglycerides, tri meaning 3, glyceride means these long chain. Okay. So this is called a glycerol molecule, which is C3, and then each of the carbon is connected to a long chain carbon or long carbon chains. These are called as fatty acid molecules. So triglyceride is made up of, triglycerides are made up of one glycerol plus 3 fatty acids. Okay, these can be saturated, where you have single bonds between the carbon atoms, or they can be unsaturated, having double bonds. The more unsaturated you have, the fat is going to be liquid, like oils. If it has no or very few unsaturation or double bonds, then this would be solids, like coconut oil or butter. So saturated fats, they have all carbons, they have single covalent bonds. They're solid at room temperature, like butter. Unsaturated have double covalent bonds and they form a bend in the molecules, so which causes a liquid at room temperature. For example, olive oil. The saturated are much more dangerous. Okay. The second type of lipid are phospholipid. So one of the fatty acid is replaced by a phosphate group. So this one is electrically charged molecule. So this doesn't have repel water like this one does. Okay, so that's what this is on top, and then you have the two fatty acid chains. This is the glycerol. So this is called as polar head. Polar means polarity, means charged, and these are called as non-polar tails. This doesn't attract water, whereas this can attract water. Okay. And then the third type of lipid are steroids, like cholesterol, sex hormones, vitamin D. Those are all made up of steroids, which has this circular kind of structure. Okay. All right, so 4 parts of triglyceride molecule is 1 glycerol and 3 fatty acid. 3 functions of this molecule, you can give any function, like it helps in storage of energy, it helps in protecting the organs. Remember, I told you in chapter 1 that the abdominal region does not have any bony cage, it's the fat that protects, right? So that is another function of triglyceride. And these fatty acid chains, they can break down to release tremendous amount of energy. So they are good storage of energy. And then how do saturated fatty acids differ? They have single bonds, whereas unsaturated have double bonds.